Of course, this is a 4-engine airplane. As you can tell, everything that we have in here, the prop controls, the throttles, the mixtures, the boost pumps, the mags, everything, there's 4 of them. So most people, if they've had any flying experience with in a Cessna or a Piper airplane, they usually had one of those, but we have to have one for each engine. They're all controlled individually. You know, we set the mixture, we set the prop controls on all four engines, and so we have to monitor all 4 engines at one time. This throttle quadrant is actually constructed fairly uniquely in the fact that if you want to use a throttle individually, you can just push like that happens to be number 1, and the handle happens to be on the top. If you want number 2, you grab it on the bottom, number 3, and number 4. But when you go to take off, it's got this center bar here, and you can grab it and push all 4 at one time. Instead of like a lot of airplanes, you'd have just 4 knobs and you grab them, but this was kind of unique to a B-17 to have this throttle quadrant like this. If you've ever looked at the cross section or looked at a B-17, it's got a huge dorsal fin, and that dorsal fin acts a lot like a windsock, and that what it wants to do, it wants to turn into the wind. And so this airplane, you end up doing a fair amount of steering it with the engines. If you go to land it, you'll run out of rudder, and when you do, you end up advancing the upwind engine to kind of help keep the airplane going straight. So it's real critical that it's where you can get to each individual throttle so that you can steer the airplane. The engines on this airplane they're 1,200 horsepower. They're Wright 1820s, and they're 9-cylinder, and this is what they call a Dash 97. They had a bunch of different versions, but this particular engine was 1,200 horsepower when it came out. You know, most of the people that have flown today usually fly airliners, and they're in a pressurized, environmentally controlled cabin, whereas obviously this is all open. The only thing between us and the elements are a little bit of glass and the sheet metal of the airframe, and that was the problem they had during World War II. They'd go up to as high as 30,000 feet, and it might be 50 below zero, and that's why they had all the heavy flight suits. Later on, they even had electric flight suits that were kind of like an electric blanket, but it was a set of coveralls you wore, and that was the only way they could survive those kind of cold temperatures for sometimes 8, 9, 10 hours at a time. There were hardly any crew members that survived the war that did not have some degree of frostbite, because they're flying in the winter over in Europe, going up 28, 30,000 feet on every mission, and a lot of them ended up coming home with frostbit fingers, hands. It was a very harsh environment. Nothing like when you're flying in an airliner, you're at 30,000 or 36,000 feet, and you got a cabin altitude of about 8,000 feet, and it's nice, you know, about 70 degrees. They didn't have that kind of luxury during World War II. It was a very, and they also had to wear oxygen masks because the airplane's non-pressurized, and if they had shrapnel from a flak burst or whatever go through the oxygen bottles, they could deplete their oxygen and could actually suffocate at altitude if somebody, because all the systems were all independent, but if you had a station that ran out of oxygen, they could actually die from lack of oxygen at that altitude. Okay, of course we're up in the Bombardier's station, which is right here in front of it. We have in this case, we have the Norton bomb sight in front of the Bombardier seat. It's actually sitting on top of a turret. And so even though the guy was the bombardier, he actually had to double as a gunner. The navigator, this happens to be the navigator table, and so the navigator would have his maps and plotters out to try to figure out exactly where they were. But they didn't just navigate all the time. As you can see, they had machine guns on each side. They had the remote mounted control for the chin turret, which was primarily used because later in the war they found out that there wasn't much defense in the earlier B-17s from a head-on attack. So they put the chin turrets in, which was remote controlled, which this is the control unit here, and when they would move it, then it would operate the gun in whatever direction they fired it, and of course the fire control was on the grip. and then the navigator would, you know, or they could take turns using these for other types of attacks. But they not only, it wasn't just being a bombardier. You had double duty. You were a gunner and a bombardier, a gunner and a navigator. Same thing. The other stations, you had the flight engineer, who, you know, he was there to, you know, any kind of mechanical issue that may develop with the airplane. But he was also the top turret gunner. And you also had in the station behind the bomb bay, you had the radio operator, and he also had a top turret gun. So 10 guys on the airplane, and all of them had more than one duty. Of course, the pilot and co-pilot, now all they did was fly the airplane, but you know, if you had to have two in case somebody got hurt, the other guy had to be able to bring the airplane back. Okay, we're in the flight engineer's position. Of course, and what he would do, they had twin 50s at the top of this turret, which was electrically operated. He would stand on this platform and be able to control the guns, and this turret would swing 360 degrees. And so if you had somebody that was attacking from the front, provided he was above the line of sight of the pilots, he could shoot, as well as anything from the left and the right. Whereas the ball turret, you know, he was only able to shoot anything that was below the line of sight, because of the guns came out below the fuselage. With all the waist gunners, the top turret, the ball turret, and the nose gunners, it gave them a full 360 degrees worth of firing capacity. That was the way the field of fire was designed, so that there wasn't any unprotected area around the bomber. And of course, then when they'd fly formation, they would stack the bombers so that there were fields of fire, so that you had multiple gunners looking in the same general area. And so if a fighter came through, they weren't just being shot at by one bomber, but by several. Of course, after the engineer station, we actually had the bomb bay, and there's a catwalk through here that we're going to walk across. Those guys back in the day, of course, most of them were, you know, in their 19 or 20, 21 years old, you know, and they were mostly 150, 160, 170 pound kids, and they could go through this bomb bay pretty easy. We'll have to kind of squeeze in a little bit just to get through it, but when they were young and agile, they could go across this catwalk like there was nothing to it. All right, of course, this is the bomb bay of the B-17. Of course, the doors are open now. They are controlled electrically. There's an electric motor through a long worm screw that actually closes and opens the doors. And what they would do is have the doors closed until right before they were going to drop the bombs. The fuselage was streamlined. As soon as you open the bomb bay, it creates an awful lot of turbulence, and it actually slows the airplane down. So when they finally got on their bomb run, they would open the bomb bay doors just before they wanted to drop the bombs. And then, of course, soon as they dropped the bombs, then they would close the door, and then, because sometimes they had to do evasive maneuvers to get away from some of the fields of flak. But as you can see, we have some 500 pounders on this side. They had some bomb loads that actually used up to a 2,000 pound bomb, but they could actually stack in here 1,000 pound, 500 pounds, or 250 pound bombs. And they had different sets of shackles that they could put on the inside and the outside of the bomb bay on each side to load those bombs individually. And they were all triggered electrically. And the bombardier up in the bombardier station, he had total control of releasing the bombs. They have a little set of latches that release each one of them individually. If one of them malfunctioned, then it was up to the flight engineer to actually walk back here with the doors open and mechanically release each one if there was a malfunction of the release. Okay, we're now in the radio room of the B-17, and they had a dedicated radio operator, and because back in the day, of course, the radio equipment was nothing like what we have today. They had all these different sets for different frequencies, and of course, a lot of the communication was by Morse code. They did have provisions of talk and voice, but a lot of the information was transmitted through Morse code. And he also doubled as what we call a top gunner, and there used to be in this particular airplane, it's not in here anymore, but there was a bracket in here that had a single 50, and he could then shoot out at the top of any type of attacking fighter. And of course, as you can see, you've got, I mean, you can shoot up anybody that was coming in, diving in from above. He'd be able to shoot at them with no problem. Yeah, a lot of people want to know how come they didn't shoot their own tails off, and actually they probably did in a few cases. But what they later found out was they had some cables that limited the where you could swing the guns, and so like the waist guns, for example, they had cables that you could only swing from one side to the other, and that way the cable would draw tight before you'd actually be able to shoot your own elevator or rudder. But early on, I'm sure they not only shot up, they had a lot of damage on their own airplanes, but they shot up a bunch of the airplanes next to them. You know, when a fighter's coming by you at 400 miles an hour and you're swinging through, I'm sure it'd be pretty easy to shoot up another airplane. So that was always a hazard of flying in a B-17. Okay, this is the ball turret, and the way that this thing operates, of course, it has electric motors that turn it and also swing it up and down. And what they have is there's actually a hatch that currently is outside the fuselage. What they do is they would roll the ball turret with the barrel straight down, and that would put the entry hatch right here. They could open the hatch, and then the ball turret gunner would then climb in, close the hatch, and then he was free to move. The problem they had was if any of this action ever got damaged, then he could possibly get trapped in the ball turret. It wasn't that big a deal unless the landing gear on the airplane wouldn't come down. If they did, then when the airplane landed, if you had to bail it in, then this whole structure was pressed up into the fuselage, and it usually ended up being fatal to the ball turret gunner. So it was not a very fun place to be. And it was very cramped. You actually sat in it in a fetal position, and you had to sit there for hours that way. All right, we're in the waist gun area of the B-17. Now this B-17 is a G model, and if you'll notice, these gun stations are staggered. This one on the right side is forward of the one on the left, and that gave the gunner free range to move about without running into the gunner on the other side. The earlier models, the waist gunners were side by side, and so they were always getting in the way of each other. Plus, on the G model, this had plexiglass to keep the elements out. So I mean, you didn't have all the cold air coming in. Whereas the F models before that, like I said, they were straight across. Plus, this was open, and so when you got it's 50 degrees below zero, and you got 200 mile an hour wind coming in here, it got pretty cold. Each of these guns have about the ammo trays hold about 600 rounds of ammunition, and which is actually only about a minute's worth of ammo. And so what they did, they were all taught to shoot in very short bursts, 2 or 3 seconds at a time, so that they wouldn't expel all their ammunition in short order. I mean, if you pull the trigger in 1 minute, you'd be out of ammo, and they sometimes had some pretty long missions. Okay, what we have here, this is of course by the aft door, is basically nothing but a generator. They call it an APU, auxiliary power unit, and what this unit was able to do is you put your starter rope, like cranking a lawnmower. You'd put your rope on here and crank it, and this generator would then, if needed, it would recharge the batteries. On a real cold day, sometimes the batteries might not be enough to actually crank the engine on a cold day, but this would then make the batteries nice and hot, and you had unlimited electrical supply. So they all had an APU here in the back. Of course, this is the tail area of the B-17. This skin that makes up the fuselage, of course, it has varying thicknesses, but most of this is only about 60 thousandths of an inch, which is not very thick. And so if they were flying through flak, which is like a shell, when it burst, it send out little pieces of fragmented steel, and it would just go right through this, just like you could poke a knife through a beer can. And that was a lot of the soldiers that were injured by flak. The flak had to travel through the skin of the fuselage first, which wasn't very hard for it to do. And so most of them later on developed what they call a flak jacket, which is kind of like an armor coat that you put on, kind of like the police do today with these bulletproof vests, and that was to stop the shrapnel that had penetrated the skin of the airplane and would hopefully stop it and not create a fatal injury. The tail gunner actually in this airplane, when they got on the ground, they would enter by this door, and then he would climb through the tail and take his station. There was a little, like a bicycle seat back there he would sit on, and of course he had an emergency bailout hatch, which was right here. And what they could do, he had a couple of levers in here he could pull, and this hatch would blow away, and so you only had to go from there to here to bail out. But it was his main job to protect the bomber from any type of attack from the rear. And so he basically had his head was here, and he was basically sitting but also kneeling, and he had total control of these 250 caliber machine guns.